Hi, welcome back to Miss Ogram's Maths. We are doing another walkthrough tutorial video today, and this one is for Statistically Based Reports, and it's from the D&D Resource booklet. So first of all, a big thank you to them for allowing me to use their materials in this way. I have put a link to their website in the video description. I highly recommend that you buy a paper copy of these booklets. For this standard and the other standards that they do, they are really excellent practice before the externals and well worth purchasing a paper copy so you can go through this properly like you would for doing the exams on paper. Okay, so this one is standard number 91584 and it is practice external assessment number 5 from their booklet. Now I'm going to assume that you have read the information in the question and then we go straight to answering it just here. So first of all, calculate the margin of error on this survey. So there are 220 people in this survey. The margin of error is equal to plus or minus 1 over root n, so 1 over 220. So that gives us, and we times it by 100 because we always give these in percentage terms, so 6.7%. Now, part 2, if we want to halve the margin of error, what do we need to increase the sample size by? Okay, so if we want the MOE to be equal to half of that, we want it to be equal to 3.37%. So 1 over the square root of n has to equal 3.37%. Okay, so let's divide that by 100 again. We've got a decimal. 1 divided by that answer will give us root n. So root n is equal to 29.66. So n, if we square that, would be 880 people. So let's see, what would we have to increase the sample size by? So if we divide that by the original 220, that's 4 times bigger. And this equation just here, if you're not super confident with your algebra, you could put that into equation solver on your calculator instead. Okay, is there evidence to support the claim that over half the respondents would buy an iPhone when they purchased a new smartphone? So the proportion that we were given for this is sitting there in the first bullet point of 54%. And the margin of error we already worked out to be plus or minus 6.7%. So the confidence interval will be 54 minus that. So 47.3% up to 54 plus, so that would be 60.7%. Now we are looking for this claim that it would be over half the respondents. Well, we don't have an interval that's entirely above 50%, so we can't support that claim. Now we're looking for 2 potential non-sampling errors in this survey and how they could cause bias. So non-sampling errors exist in the way that the survey was conducted and are usually like human things that we would normally try to accommodate for and try to remove. So within this survey, it was the news crew that went out at a particular time. It was between 12 p.m. and 2 p.m. on one weekday, and so there are some issues with that. So we'll pop a couple of those down. There are other options too, and there'll be more in the back of the booklet, but the 2 that I'm going to put down, we're going to start with the fact that they were doing this at a time of day that excludes some people from being able to be part of the sample. So there's some ideas and details expanding on what I mean there. You could also put things down like it depends the area that the mall services. If it's one of the highly affluent areas, then you're likely to get different responses than if it was a mall that was in one of that serves an income a community that has an income that's a bit lower than average. Okay, the second one, because we've been asked to do 2 potential non-sampling errors, we can talk about the fact that this was done by an interviewer, so that could influence either the way that questions are asked or responded to. Okay, if we assume this survey is representative of all smartphone users in New Zealand, can a claim be made to support the headline that the iPhone market is set to increase? And we need to show one confidence interval as part of our answer. So let's start with the existing market share from the people that were in the survey. So 80 of them had iPhones out of 220. And I made a mistake there. There we go, 220. So that is 36.6%. And the ones that wanted to buy a new, if they're buying a new phone, they said that they would buy an iPhone, was 119 divided by 220, which is 54.1%. Okay, so the difference, if we subtract them, is 17.7%. The margin of error on the difference is we have got 2 independent groups. We've got a group. The existing group is independent to the new group. Or rather, that's an assumption that we're making, but because what we're doing here is assuming that their current, the thing that they currently have doesn't influence what they choose to do next, which may not necessarily fit, but it's the closest thing in working out these margins of errors for this situation. We're not looking at the proportion from within one group. We're doing 2 distinct groups that we've classified this into. So that's a 1.5 times thing of the average of the 2 margins of error. The margin of error is 1 over root n for each of them. Now we've got 220 in both groups because both groups came from the same sample for what they have already and what they would buy new. So let's pop that in. We've got 1 over square root of 220. If we add them together and half it, it's just going to come to the same thing. Now times it by 1.5, times it by 100, and we have plus or minus, just fix that up, plus or minus 10.1%. Okay, now the confidence interval. So the confidence interval on the difference is going to be 17.7 plus that 10.1 and 17.7 take it away. Okay, so 17.7 take away 10.1 is 7.6%, and add it on is 27.8%. Now, since that interval is entirely positive, it doesn't contain 0, it means we can make the call that we expect that difference to be positive, for there to be an increase. Now for question 2, we've got some information here about adult smartphone ownership. Expected to hit 79% in 2015, and this article is quite old now. It was done in November 2014. Okay, first is about the margin of error. We want to show how it was calculated to be plus or minus 3%. That's down at the bottom of the article, where it tells us that the number of people surveyed was 1,088. So the margin of error is equal to plus or minus 1 over the square root of 1088. Which we can show equals plus or minus 3.03%. We're going to use it to create a confidence interval next for the true population percentage of New Zealanders who owned a smartphone in September 2024. So if we go back to our article, we can see that information on the second paragraph down where it says a Horizon Research survey finds 69% of people have smartphones. So the proportion stated was 69%. So the confidence interval is going to be 69 plus or minus the 3%. So 69 minus 3 is going to give us 66%, and plus 3 is 72%. So that's where we can expect the true value to lie. All right, the target population is going to be all New Zealanders aged 18 years and older. If we want to identify one of the survey percentages that shouldn't have this margin of error applied to it, we're looking for any of those percentages that are outside of the range of 30 to 70%, because that's how we know we can apply the rule of thumb. The question did only ask for one of those, but since they were right next to each other, I've put two in here, so it wouldn't be appropriate to use it on the 15% of all women, or the 5.4% of men who say they intend to get a smartphone in the next 12 months, because that lies outside of the 30 to 70% range in which we can use that rule of thumb. This last question about results weighting, we need to explain what that means. So the census data was used to work out the proportions within the population. And in particular, we can think about the male-female split, because that's what this article has been talking about, differences between men and women throughout. So the results that we get for the survey would be weighted to match the proportion of male and female that we have from the census data. And here's where I've had a go at writing that out using an example. So if our responses from males in our survey aren't, we don't have as many responses as we would expect for the proportion of the population, we could give them a higher weighting to counteract that. For part D, we want to test if there's been a difference. So the 2014 proportion was 69%. 2013 we've just been given as 60%. The margin of error in 2014 we'd worked out previously to be plus or minus 3%, and we've been quoted a margin of error in 2013 to be plus or minus 3.2%. So now we want to work out a confidence interval on the differences. So the difference is 69 minus 60, so that is 9%. Margin of error on the difference, we've got two clearly different independent groups, so that's a 1.5 multiplier of the average margin of error. So half of 3 plus 3.2%. So that's going to be equal to plus or minus, so 1.5 times 0.5 of 3 plus 3.2. So that's a plus or minus 4.65%. So our confidence interval on the difference now is to take that 9 and add and subtract 4.65. So 9 minus 4.65. 0.35%, and then if we're to add it on, it'd be 13.65%. Now that is entirely positive, so we can make the claim that it is going up. For question 3, we've got this article about McDonald's and moving to serving all-day breakfast with some information about how that information was collected. Okay, so first is there statistical evidence to support the claim that in the UK, the majority of adults support extending the McDonald's breakfast serving hours, and we need to do a confidence interval as part of that decision. So the first thing is to set ourselves up with a margin of error. For this, the number of people that were surveyed was 1,500. So our margin of error is plus or minus 1 over the square root of 1,500. So that is plus or minus 2.6%. Now construct our confidence interval. Well, the quoted statistic is 59%. So we're going to subtract 2.6 from that. So 59 take off 2.6 is 56. Oh gosh, I can't write today. 56.4%. And if we add on 2.6, it is 61.6%. Now that interval is entirely over 50%, which is what we need for a majority, so we can make the claim that's being asked for in this question. Can a claim be made that a high percentage of US people support extending the hours versus UK? So we're going to construct a confidence interval on the differences. So in the US, we have 76% as the proportion. In the UK was 59%. So the difference between the two, 76 minus 59 is going to be 17. The margin of error for the US is plus or minus 1 over root n. Well, in the US, the survey was only on 1,200 people. In the UK, we already worked out the margin of error in the first question. That's plus or minus 2.6%. So the US one divided by square root of 1,200. And then times it by 100, so that's plus or minus 2.9%. Okay, now the margin of error on the difference. These are two independent groups, so we're going to do 1.5 times the average of those two margins of error, so put 2.9 plus 2.6. Okay, so 1.5 times half of 2.9 plus 2.6 comes to plus or minus 4.125%. Now our confidence interval on the difference, we're going to do our difference of 17 plus or minus the margin of error on that. So if we take off, so 17 minus 4.125 is 12.9%, and then 17 plus 4.125, 21.1%. And this is entirely positive, so we can make the claim. Next, why would it be inappropriate to use the margin of error of plus or minus 2.6 that we've been using so far in the UK survey to construct a confidence interval for the percentage of UK adults who chose the breakfast wrap as their favourite breakfast dish? Well, the proportion that we've been given for breakfast wrap as their preferred dish is 4%. And that is too small to apply a general rule of thumb formula for it. When we're dealing with values outside of the 1370, we then use this formula instead. So this would be equal to, now the proportion we've got is 0.04, we times it by 1 minus the proportion, so 0.96. Divide it by n, which is 1500, square root our answer, and then times it by 2. So that is plus or minus 0.0101, much smaller than the rule of thumb. And that's because extreme responses always have a lot less variation to them. When you're dealing with things in the middle, there's a little bit of give and take. But when you're at a very low percentage or a very high percentage, people have very strong opinions of those things to produce such extreme numbers. Okay, last part. We've got a panel of over 360,000 British adults that YouGov use. Then they draw a representative sample for any survey that they are running. They invite that subsample to complete the required survey. Everyone who takes part receives a modest cash incentive, and once the results are received, they are weighted to a national profile. So let's identify some possible advantages and disadvantages of offering a cash survey to complete a survey. So starting with an advantage, it increases the likelihood the survey will get done if you're going to pay people for it. And then potential disadvantages, you can have respondents that are in it only for the cash and don't pay good attention while they're going through it. They're just doing it to get it done and just get the money, so then they might not be truthful or do it in depth, etc., etc. You also might end up having it overrepresented with people who are motivated by money, and that might impact on the type of survey that you do. So if you were doing a survey that asked people, are you more likely to complete a survey if you are offered a cash incentive to do it, then, and if that survey does have a cash incentive attached to it, you are going to get people answering positively more to that, because they're the ones that have actually stopped to do that survey, because it's sort of a self-fulfilling prophecy. There could be other things that you put into this question as well, as long as you justify them adequately, but those are a couple of examples from me. Okay, that's the end of this paper. If you find this helpful, then please do interact with the video, leave a comment. I like to hear from people, but also it helps other people to find this video too. And if you found it helpful, I'm sure there's somebody else that would benefit from it as well. So just appreciate you doing that as well. Thanks. See you next time.